Hello everyone. Today let's solve the problem 763, right? Partition label. So let's see what the question states here. We are given a string s, right? So see here, we are given a string s, right? So partition it into as many parts as possible, right? Partition it into as many parts as possible, so that each letter appears in at most one part, right? So that each letter appears in at most one part. So we have to return a list of the sizes of those parts in order, right? So what we need to do here, we have to return a list of the sizes of those parts in order, right? So this is fine. Now see here, they have given us wonderful example. S equals this one, ABC, ABC, AB, ABC, BA, CA, DE, FE, GDEHI, JHK, so this one. So we have got the output 978. How is this possible? See here, the partition is AB, ABC, BA, CA, right? And DE, FEG, DE, same letters, this one, group of same letters, right? So see here, basically this consists of the ABC. This is DEF basically, right? DEFG, DEFG, right? This one HI, this one JKL, HIJKL, this one, right? So this is the partition, so that each letter appears on at most one part, right? So that's what a partition like this one, this entire word. This one is incorrect. Why they have given this one incorrect? Because it split S into less parts. Here we can split this one into 3 parts, right? 978, right? So this one C consists of ABC, DEFG, HI, JKL, right? So this one you can clearly see, right? Same goes with the example 2 as well. You can just get go through this one. This is fine. So output that we need to get here is 10, only single one. We'll go with actually BCDE, right? So BCDE will be going with. So we'll be making use of this one. Total will return this one 10 itself. We have 10 letters, I think. 1, 2, 3, 4, 5, 6. So this one has to be 10 basically. 6, 7, 8, 9, 10. Yep. So this one we have got in the terms of 9, 7, and 8. This one 3 partitions, right? So this one from ABC, this one we have got this one. DEFG we have got this one, which consists of the 7 letters, and this one we have got 8 letters, which consists of HIJKL. This is fine. Now let's do one thing. As we are completely familiar with the approach and the question and the example, now let's do one thing. Let's quickly discuss the approach. Just give me a second here. Yep, 1 second. Yep. So let's do one thing. First let's go with the this one. Let's consider the first example, this one itself. Before getting into the approach part, let me tell you one thing. So we will be going with a greedy approach to solve this particular problem, right? So we'll be going with a greedy approach to solve this particular problem. So what we'll be doing, let me tell you the idea. So we will be recording the last index of every character. So last index of every character, right? So we'll be recording the last index of every character, then scan the string s, keeping a running end equals max of last sign for the characters in the current window, right? So whenever the current index I will be equivalent to the end, then we can cut a partition at that point of time, right? So let's apply the same thing for the example 1, so that we understand the approach clearly, right? So we will pre-compute the last occurrences in the first part. So we'll go with the frequency. So A, this one we have 8, right? Last occurrence of A. So this one B, the last occurrence of B is at 5. So I can just clearly see here 0, 1, 2, 3, 4, 5. So this is the B last occurrence, right? 6, 7, 8. A's last occurrences is 8. So that's what we'll be doing for every character. For the C, it is the last occurrence of C is at the 7th index, right? For the D, it is, you can just check, it is 14, right? So I have already done this one, D 14. So E, for E this will be 15. The last occurrence of E is at the 15th index. For the F, it is at the 11th index. This is also fine. And for the G, it is at the 13th index. This is also fine. And for the H, it is at the 19th index, right? For the H, it is at the 19th index. For the I, it is at the 22nd index. This is fine. For the j it is at the 23. For the j it is at 23rd index, the last occurrence, and the last occurrence of k is at 20th index. This is fine. And for the last occurrence of L, it is at 21st index. So we are just marking the last occurrence of each letter, each character here, right? So next what we'll do, we'll start scanning. We'll start scanning this one, right? So I equals 0. When I equals 0, this one first iteration, when I equals 0, so A, so here A, A to end, nothing but the last A equals 8. We know this one, right? As we can scan 1 to 8, any character's last index has to be less than or equal to 8. So end stays at 8 itself. So end stays at 8 itself here, right? So this is fine. So when I reaches 8, we will cut the partition size, nothing but 8 minus 0 plus 1, right? 8 minus 0 plus 1, because indexing starts from the this one 0, and so we'll be going with a plus 1, as we have to go with the correct length, right? And length starts from the 1 basically, right? So this one will be going with 8 minus 0 plus 1, nothing but 9. This one we have got 9 here, right? So this is one when I equals 0. So when I equals 9, so we have moved to 9 because A is this one, from the previous step we have got 9 here, sorry. Yeah, now we will continue from I equals 9. So I equals 9, the next this one is, we have to consider D basically. See here, this one next to A we have D. I equals 9, 9th index we have D, right? So D will mark this one to end equals last of D. Last occurrence of D is at this one. See, we have already written this one. Last occurrence of D is at this one, 14. First last occurrence of A was at 8, so this one is at 14 basically, right? So the last occurrence of D is at the 14. So encounter E with the last. Again, E is at the 15th, last 15th index, right? So the last occurrence of E is at the 15th index. We will extend N to the 15 when I matches 15, right? So then we will cut the size from this one, 15 minus the previous one. The length we got here is 9, right? So now we got 15 minus 9, the previous one, plus this one 1, as we are dealing with a 1 based indexing, right? So this one will be 15 minus 9, nothing but this one 6 plus 1 is nothing but 7, right? So 7 is the thing that we got here, right? 7, this one 7 is the output that we got here basically, right? 7 is the output that we got here. So next we will be considering the next 7 letters here. So D, E, F, E, G, D, E, this one until this one. What do we call 1, 2, 3, 4, 5, 6, 7. So until E, this one, right? So this is fine, man. Now 9, 7 we got, 9 we got, 7 also we got here, this one from the second step. So let's move on with the next step. So we'll be going with the remaining part. Remaining part starts from 16. So we have stopped at the 15th index, nothing but E. Remaining 16th index is H here, right? So remaining part starts at 16. So this is the final partition. We have got 16 here. So this is the final partition until the index 23 basically, right? So until the index 23. Size is nothing but 8. This time size is nothing but 8, right? So size is nothing but 8. So this is from this part H, this part of H to this one, what do we call J, H to J. So this one 8, we have got 8 for the final partition, right? From H to J basically, right? So this is fine. Now we have got the output 9, 7, 8. For the first partition we got 9, for the second we got 7, and for the third we got 8. So the output that we got here is 9, 7, 8, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct in this case. As our approach works absolutely correct, and as we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be pico of n, right? So the time complexity would be pico of n. right? So why it is big of, and we are going with the greedy, and we'll be going with the one pass to compute the last occurrences. Also we'll be making use of one more pass, nothing but one pass to form the partitions as well. So overall time complexity would lead to big of n. So what will be the space complexity, as we are making use of the greedy? So the space complexity would be big of 1, because we'll be going with only the last array, which is of the size 26, and output lies within the big of k. Big of k meaning here k is nothing but the number of partitions, right? So we know this. So we are not making use of any extra space, right? So we are making use of only few variables here in this case. So overall space complexity would lead to big of 1 as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively, right? So let me delete this one. So as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? So first thing here would be, let's go with the result list to hold the this one sizes of the partitions. So here now let me go with list integer. So this one result equals new array list of let me go with integer. This is fine. First we are going with the result list. This is fine. Next we have to go with the array. Why? Because we have to store the last index of each lowercase letter, nothing but we have 26 letters here, right? So let me initialize last to the this one, a new int of 26, as we have 26 letters. This is fine. Next step is we have to fill the last with the last occurrence index for the each character accordingly with the index. Let's go with the iteration part here. So this will be for int I equals 0, I less than length of the string, nothing but in our case it is s. So didn't I type s here? This is fine. I plus plus, so java. So let me give the parenthesis here. This is fine. Now within the for loop, so let's get the caret I, let's subtract a to map to 0 to 25. Let's store the latest index I, nothing but let's store the latest index I as well. So we can just write it on this way, last of s dot caret. So this one is fine at I, so this one is hyphen a. Oh, this one is fine equals I. So now this is fine, and let's go with the start index of the current partition window. So when I say this one, let me initialize start to 0, and also we have to go with the end, that is the farthest index any character in the current window must reach, right? So I'll just go with int end equals 0 as well. The next part is again the iteration, right? So we have to iterate through the string and expand the end greedily, right? So we are going with the greedy approach basically. So this one will be int I equals 0 less than length of the s, finally I plus plus. So within the for loop, let's update the end to be the farthest last occurrence seen, that is seen so far, right? So this one will be end equals math dot max, this one end comma last of s dot char at I, this one hyphen a. This is fine. Next what we'll do, when the current index reaches the end, then we can make a cut here. So this one will be if I equals end, so we have to add the partition size end minus start plus 1. So result dot add, so this one will be end minus start plus 1. This is fine. So the next partition starts at the next index, meaning start equals I plus 1. This is fine. And we have to return the list of the partition sizes. So I'll just go with return result. So this is fine. Now let me format the code once. Let me hit the run button. What mistake I have done here? So this one, yeah, new, this one I have not given parenthesis here. This is fine. Now this has to work. So this this I has to be capital. This is also fine. Cannot find. This one has to be array list, right? So I have given arrays list. This is fine. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases. Yeah, you can clearly see here all the test cases are getting passed, right? So whatever the code that we have written works absolutely correct, right? So here now I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.